Welcome back my dear friends, a very good morning, good afternoon and good evening to all of you. And as you know, this is the DADM2, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. And we are in the lecture number 8, which is in the second week. And as you know, this course is for 12 weeks, which is 30 hours. And the total number of lectures is 60, because each week we have 5 lectures, each lecture being for half an hour. And after each week we have an assignment. So, we are in the second week. So, the moment you finish this, that is the 10th lecture is over, we will have the second assignment. And my name is Raghunandan Sengupta from the IME department, IIT Kanpur. So, if you remember, we were discussing about utility theory and the concept that how you can find out the concepts of utility theory, then considering the different type of utility theories like the logarithmic one, exponential one, power one and the quadratic one. How you can find out the values of A and A prime, where A is basically the absolute risk aversion property, and then also find out R and R prime. Prime means the first derivative with respect to W we are finding out, where W is the wealth, where R is the relative risk aversion property. Then we saw that how these A prime, R prime can give us some information about the utility function depending on whether you are risk averse, whether you are indifferent to risk, whether you love risk. And then we also saw the concept that how you can basically utilize very simple concept of drawing in a graph paper or in a Cartesian coordinate, my apologies, how you can use the concept of graph paper, draw the concept of the A and B, which are the gamble, the values on the gamble, considering it is a fair gamble, and also the certainty value. You can find out what type of property the person has with respect to his or her utility function, whether it is concave or convex. And then we slowly went into the concept that if utility function is quadratic, I did mention that though fleetingly, that if the utility function is quadratic, then there is some relationship with respect to the returns being normal and vice versa. So, we will come back to those 2 slides again, as I did mention after at the fag end of lecture 7. So, I will again repeat the same problem, please bear with me. So, we are trying to compare between the mean variance and the utility function. The utility function is quadratic, which is of the form AW plus BW square plus C, and here it is given as W minus B into W square, which is a quadratic function. Consider we have 3 assets and the prices are given. Assets mean financial assets. So, it can be translated into any decisions, like you have 3 projects, 3 decisions, whatever it is, but I am keeping it very simple. The first, I will again repeat few things, please again I will request you to please bear with me. The first column are the numbers, the second, third and fourth column are the respective values of the returns, not the returns, the prices or the wealth, whatever it you say, for the 3 different assets or 3 different projects or 3 different decisions, which are respectively A, B, C. And in the 5th, 6th and 7th column, which is given as R A, R B and R C, are the respective returns corresponding to the decisions or the assets or the projects A, B, C respectively. And on the last column we have the probabilities. I am taking the probabilities as equal in order to make our understanding much simple. So, based on RA, RB and RC, we will find out first the average return, we will find out the standard deviation and then proceed considering the mean variance theorem and the utility theory. So, basically we are trying to compare mean variance concept for the decision on one side and the utility function based on the fact it is a quadratic utility function, remember that, on the other side, and then try to basically find out the similarities and basically draw very interesting conclusions about that. I am not going to go into the proof, but I will just state it as a matter of fact, but try to utilize that for our decisions later on. So, we find out R bar A which is 1.06, R bar B which is 1.05 and R bar C which is 1.14. And the standard deviation, we are just using the same symbol as sigma. Technically it should have been the, if you remember the concept of DADM 1, actually many of you would be basically interested and trying to question, and rightly so, that why do not we use the standard error for the sample, but I am just using the symbol for the population in order to make our life simple and understanding very realistic. So, obviously, you will be then thinking, I am coming back to the slide, then you may be thinking that if you are using standard error, all these things, then we should be using the other 3 distributions corresponding the normal distribution as the t distribution, chi-square and the f distribution. We will not go into that, we will just simply use the standard normal distribution. That is only for making you understand. So, again coming back to the slide. So, we have sigma suffix a, sigma suffix b and sigma suffix c. The values are 0.025, 0.022, 0.052, and we will consider the average weights as 114, 119 and 100. So, the bar means the average. So, if riskless interest, which is the bank interest which is paying, which is given as 0.5, then we are interested to find out that what, according to the mean variance analysis, how do we rank the assets, how we are able to rank the assets. Assets means the decisions. I am using the word financial assets for A, B, C, but it can be a project, as I said, it can be a decision, whatever it is. Now, our actual analysis is, I will write it, I am sure all of you are aware of that. So, basically what we need is, we need the probability of x being greater than equal to x, small x. Now, let me expand the discussion. So, I want to find out, I will draw the distribution here. Now, this greater than or less than would depend on what type of, which side of the distribution are you looking for, corresponding to the fact whether you are looking at the excess distribution or the negative side of the distribution considering is a loss distribution. So, the concept whether you want to earn more would definitely depend on how much positive side it is, and if you want to basically maintain a loss which is as low as possible, and if it is a loss distribution you will try to basically be on the left hand side. And if I am looking at from my point of view, that means the middle value will basically give you no loss, no profit. On the right hand side you have the profit, more you go on to the right you have higher profit, more on to go into the left is basically the negative profit, which is the loss. So, this greater than sign and less than sign would basically depend on which side of the distribution you are looking at. So, let me consider the positive side only. So, now if we have basically x, so I am having I am drawing x, small x here. So, what I am interested in, I will highlight it with yellow onto the right hand side. So, if I come back to the calculations very simply, it is probability x minus, now considering the normal distribution we will have the expected value of x and the standard deviation of x, and consider this is alpha. So, variance of x square root, which is the standard deviation, is greater than x minus e of x. This small x is a realized value, remember that. So, this will basically be converted into standard normal, this becomes capital Z and this becomes small z. So, you can find out from the tables. So, higher the value, lower the value, you can basically pass your comments or judgments accordingly. Judgments based on the fact that how you are going to rank them. Now, with this, let me come back to the slide. So, what we are considering is there is a risk free interest rate, and this risk free interest rate, by the way, this risk free interest rate actually would be coming into this value x minus a fixed value. So, which is basically RB or RA or RC minus RF. Now, RA, so these are the bar values, average values. So, RA bar, RB bar, RC bar are non-deterministic. If you take values repeatedly, obviously the sample averages would keep changing depending on the samples being different. So, if you find out those values and rank them, so you have basically, as if you find out it is R bar B minus RF divided by sigma B, then another value would be, probability would be R bar A minus RF divided by standard deviation, which is sigma A, and another is R bar C minus RF divided by sigma C. So, these values corresponding to those three statements which I made come out to be 25, 22. I am not going to the decimal values 25, 22 and 12. So, if you plot them along the x axis and then try to find out the one-to-one correspondence with respect to the standard normal, you can rank them immediately, where B returns are greater than A returns are greater than C returns. Now, this was based on the fact that you are considering the concept of mean variance concept. Mean means these bar values were the means, and the variance was basically corresponding to the fact that you are taking the square root of the variance, which was the standard deviation, which is sigma A, B, C depending on the suffix. Now, you have ranked them. Now, you want to find out the ranking which you have done based on the fact that you are taking the mean variance concept, whether it matches with the quadratic utility function, because the mean variance was done on the normal distribution concept. Now, using the quadratic utility function, giving a value of B as minus 0.002 when we rank them and find out the utility values of A, B, C. So, it comes out utility of B comes out to be, I will not repeat the second place of decimal, it comes out to be 90, for A it comes out to be 88, and for C it comes out to be 80. Now, remember here, even though I have written the probabilities on 1/5 for all the cases, we are not considering that. This you can change the probabilities, that would not have any effect on the calculations. So, if you do that, and then the ranking again becomes higher the utility, better for you. So, B is greater than A is greater than C. So, the ranking which you got considering the mean variance concept and the utility concept comes out to be the same. That means, B is the best, A is the second best, and C is basically the third best. So, the ranking system which you did corresponding to the fact that you are taking the quadratic utility function and the normality distribution, which leads out to the fact for mean variance concept, are the same in the sense they give us the ranking concept and the decisions the same. This will become very important later on when we consider the different type of decision process for different type of examples. Now, let us consider further on. So, consider the following examples with two different sets of outcomes. The utility function is again quadratic, which is w square plus w. So, it could have been a w square plus d w plus c, anyway it does not matter. So, the outcomes are given, and outcomes for scenario 1 is given as, if you look at the first column onto the table, where I am not going to mark it, but I am just highlighting. This is the first column for scenario 1. This is the second column corresponding to scenario 2, and other values I will come to that later on. So, the outcomes for scenario 1s are basically 15, 20, 25, 10, 5 and 25, which is the first column. The outcomes corresponding scenario 2 is 20, 12, 25, 17, 8 and 30, and the corresponding values of W, which is the wealth, UW, which is the utility function based on the fact you are going to consider the quadratic utility function, and probability are given. So, now how do we find out the probabilities? We are trying to basically find out the outcomes both outcomes corresponding to utility 1 divided by the total number of outcomes. So, the total number of outcomes if you add up for scenario 1 and scenario 2 comes out to be 212, 212. Now, the probability corresponding to the fact, if you only concentrate on the first row, the probability corresponding to the fact that you have the utility as 3.75 corresponding to the fact that the wealth value is 1.5 comes out to be this one. 15 plus 20, which is 35 divided by 212, and if you follow the last column, the probabilities are given. So, for the second row, that is for the utility of 6, it will be 32 by 212. For the third row, which is the utility is 8.75, the value of probability comes out to be 50 by 212 and so on and so forth. So, accordingly we have to calculate the expected utility value and basically rank them accordingly. So, they can be two different utilities, they can be same utility with the corresponding fact that you are trying to use the mean variance concept, whatever it is. In all the examples we will see that I am again repeating it, if the utility function is quadratic and the distribution corresponding to the utilities, that I am basically investing some money, I am getting a utility, I am getting a return also. So, utility as I mentioned, it is quadratic and the returns are normal, then the one to one correspondings based on the fact that how the ranking system would be done would be same for both these decisions. Now, whenever we are considering a utility, always remember our main aim is you have a gamble, need not be fair, point 1. Point number 2 is that there need not be only two outcomes, there can be multiple outcomes. So, let us consider the example which is given in the slide. So, concentrate on the figure which is on the left hand side where I am just hovering the pen now. So, this one. So, let me highlight it. So, this value. So, now if you look here, what do you have? You have probabilities P1 and the outcomes are given as W1, P2, W2, P3, W3, P4, W4, there can be more outcomes also. Now, remember 2 or 3 very simple things which are true corresponding to the fact that we are considering these examples. Point 1, the sum of the probability should be 1. Point number 2, the values which are given as W1, W2, W3, W4, remember they are the outcomes. So, if they are based on the fact that those are the wealths, so obviously you have to convert those wealth or those decisions into the utility based on the fact that what is the utility function. So, if you have the utility function as quadratic, so for W1 you will basically find out the quadratic utility function based on the fact that the wealth is W1 or the general returns is W1 or the decision is W1. Similarly, for W2 it will be quadratic function based on W2, similarly for W3, W4, W5, so on and so forth. Now, if the values are given as it is, that is W1 is the utility function or W2 is the utility function, you do the calculations accordingly. So, for the left hand side, if I ask you or if I ask any one of the decision makers to find out that what is the average value, so what you will do? Considering the fact that W1, W2, W3, W4 are the corresponding utility functions, you will basically multiply P1 into W1 plus P2 into W2 plus P3 into W3. So, your actual value for this decision, I am using a different color, would be summation of Pi Wi I is equal to 1 to n, and if this is not valid corresponding to the fact that W1, W2, W3 are not the utility function, you will basically replace that with summation. I am not writing the limits, probability Pi into u of Wi, whatever the u functional value is. Now, if you consider the diagram on the right, so what you are doing is this, I will use the blue one, yes. So, what you are doing is that for each of the values of W1, we are replacing them with a fair gamble, in the sense W1 can be replaced by two outcomes, probabilistic, probabilities are H1 and 1 minus H1, and the values being B1 and 0. Now, H1 and 1 minus H1, if it is a fair gamble, the values will be half, and the corresponding values of B1 and 0 would be based on the fact that whatever the utility function you are utilizing for W1, if at all it is a utility function, then you will use the same utility function on the right hand side for the diagram which is given, which I basically circled using the green color. Now, the fact remains that if W1 is by itself a utility, then you will basically find out what is the utility function and use that utility function to convert B1 into its corresponding utility and 0 into its corresponding utility. So, what you are trying to do is that you are trying to find out the one to one correspondence between the value of W1 and B1 into H1 plus 0 into 1 minus H1 such that the expected value on the left hand side and the right hand side are the same, which means W1 in general should be equal to B1 into H1. I am using the same blue color in order to make you understand, plus 0 into 1 minus H1. So, this if I replace for all the values, it will be Wi, Wi, Bi, Hi and Hi. So, if the probabilities are same, so Hi becomes half, 1 minus Hi becomes half, and you can do the corresponding calculation. So, this can be made as you go more on to the right. B1 can be further broken down into, say for example, C1 and 0, and the corresponding probabilities can be made accordingly. And if you go on to the left here, then obviously the overall decision is basically the expected value is, you will basically have a certainty value, you can use the certainty value to match the gambles. I am not talking about the fair gamble, they can be gamble with probabilities being different onto the left hand side and right hand side. So, you are able to find an unique value of C, which would basically be able to replace the overall different type of non-deterministic decisions. But remember, the utility function which you are going to utilize throughout for all the decisions should be the same. So, decisions and utility analysis. So, people have other criteria for investment, projects and portfolio selections for decisions. So, they can be geometric mean returns, safety first criteria, stochastic dominance, and there are other analysis in terms of characteristics of return distributions. So, we will basically go one by one from considering that. The first one being basically be the geometric mean returns. For the selection process, we consider the maximum geometric mean returns, which is basically it means that it has the highest probability of reaching or exceeding any given wealth levels in the shortest possible time. So, you want to basically find out the highest probability corresponding to a fact for a certain time period, you want to basically exceed that. And another concept would be the highest probability of exceeding any given wealth level over any given period of time. So, the fact remains that in one case the time is fixed and you want to find out the highest probability, and another case that time may not be fixed, still we want to find out the so called expected value based on the fact that the values are the same, but the probabilities obviously should be as high as possible. I will come to that concept when we solve very simple problems. Now, remember these are just to initiate the interest for utility functions, and that if the two utility functions are same, that how are we able to take a decisions, whether decision 1 or decision 2, which one is better. We will just utilize them from the multi attribute decision making concept or non parametric decision making concept. We would not go into the mathematical details, but try to utilize the concept wise the logic when you are trying to basically make different type of decisions. So, consider the returns being given by the suffix I and j. Ith is a possible return on the jth portfolio, and obviously there would be for each portfolio, so each decisions j can be basically from 1, 2, 3, 4, 5, 6 till capital J. So, I will consider that, let me use the red color. So, j can basically be capital J, and similarly I can be basically possible to capital I. and the probabilities are given by Pij. Now, if you remember, for any decision the probabilities from of I 1, 2, 3, 4 till capital I, if you sum them up for that corresponding value, it will be the probability corresponding to the decision small j. Similarly, j can be 1, 2, 3, 4, 5, 6, we will find out the probabilities. Now, Pij is the, and obviously we will also check the corresponding fact that the sum of the probabilities should be equal to 1. I will come to that later. So, the probability of the ith outcome for the jth portfolio is basically Pij, and we should basically choose the decision for which the geometric mean value basically gives us the maximum so called return. Return means capital R, it can be small r also. Now, let us come back to the formula. If you remember, I won't digress, I will just come back to one example. For investment, if you remember, the reason why I am saying that in the investment purpose we will always use the geometric mean. Now, let us step a little bit, take a not a detour, step sidewise. If you remember, when we are considering the concepts of in DADM1, I did mention that the general characteristics of the mean values can basically be considered using the concept of average value, which is mean. Mean can be arithmetic mean, mean can be geometric mean, mean can be harmonic mean. Now, in the geometric mean example, I did mention that when you are trying to consider different type of returns for decisions, we generally take the geometric mean. So, that is the basically the simple history based on which why we are taking this geometric mean. And for any decisions, financial facts being very important, they would always consider that geometric mean concept to be true in order to make that decisions accordingly. So, Pij are the probabilities of the ith outcome for the jth portfolio, then we choose the maximum of the geometric mean value. So, what we will find out is that for any portfolios, any decisions, we find out the probabilities Pij we have already found out, we will find out the corresponding so called average value, which is RGJ. J is basically for each and every decisions. So, what you will do, you will find out 1 plus R1 to the power Pij and multiply them corresponding to the fact and then subtract the value of 1, because in the geometric case you are trying to utilize the geometric mean. So, if you consider that, let us corresponding focus our attention to this problem. Consider we have the following combinations of assets. Assets again I am using in a very general sense, it can be any decisions, any projects, whatever, are ABC in the ratios where the returns are 10, 20, 30 respectively, and we consider the A has this combination of the assets which is ABC for portfolio 1 or decision 1 is 20%, 20%, 40, 60%, which adds up to 1. For portfolio 2 with decision 2 or project 2, they are equivalent to the fact that each is 1/3, 1/3, 1/3, which is 33 and 1/3 and 33 and 0.33 value. And when you come to portfolio 3, which is decision 3 or project 3, the investments for ABC are 25%, 25% and 50%. If you utilize that, you can find out the RP1, the portfolio value for decision 1 comes out to be 23.7, for 2 comes out to be 19.7, for 3 comes out to be 22.2. So, obviously, you will choose the decision 1, and these calculations can be done for different type of probabilities corresponding to the fact that geometric mean is the main deciding criteria based on which you are going to take a decision. And you will see that these different methods gives a different ranking system. It does not mean that one ranking system for a decision is worse than the other and one is better. It is basically how you analyze the problem from your point of view and what you consider your utility function, point 1. And also these distributions will come out to be important later on, we will see to that, come to that later on in the fag end of this course, and obviously some of the examples will be considered in the DADM 3 course also, which will lead on us to the fact that how we are going to utilize the optimization concept in decision making, and that those would be parametric optimization. I will come to that later on only, but let us basically concentrate on DADM2. So, with this I will end this 8th lecture and continue discussing further on depending on the utility functions, and then most probably by the 10th lecture or the 11th lecture, which 11th lecture would be the 3rd week, we will start the actual concepts of different type of non-parametric decision making. With this I will end this lecture and have a nice day, and thank you very much.